Welcome back to Section 6, Lesson 1. Here we are looking at the number of solutions for a linear system of equations. So in example 1, we have to determine the number of solutions for each linear system. So to do that, we can compare the slopes and y-intercepts. So I'm going to change each of these lines into the form y equals mx plus b. So for the first equation, x minus y equals -3. I'm just going to bring the negative y over to the right-hand side and the -3 over to the left-hand side, giving me y to be x plus 3. Now for the second equation, I'll start by bringing -4x over to the right-hand side. Then I'll divide each term by 4. So when I simplify that, I get y equals x plus 3. So now putting these two equations together, we have this system here. So you can see that we have the same line. The slopes and y-intercepts are the same. So whenever that happens, we can say we have an infinite number of solutions. Now after rearranging these equations, it was obvious that these two lines were equal. But not so much for the original system. But upon closer inspection, you might notice that the second equation is the first equation multiplied by -4. So if you happen to notice that one equation is a multiple of the other, then you can state that and then say that there's an infinite number of solutions, seeing as they're just the same line. Now looking at the same system for a moment, I want to show you what the solution would look like if you did try to solve this using substitution or elimination. So say I wanted to eliminate x from the system. I'll start by multiplying the first equation by 4. When I do that, I would get 4x minus 4y equals -12. Now I'll write the other system right underneath it, and then add the two equations together. So now 4x plus -4x is 0. They cancel out. Now look at the y's. -4y plus 4y is 0 as well. And same for the right-hand side. -12 plus 12 will give us 0, leaving us with 0 to equal 0. So in the future, if you see this when you're solving systems of equations, you can say that there are an infinite number of solutions. Now for b, I see that the first equation is in slope point form, so I see that the slope is 3/5. So let's go ahead and find the slope of the second equation by writing it as y equals mx plus b. So I'll start by bringing 3x over to the right, and then I'll divide each term by 5. When I do that, I get y to be -3/5x plus 1/5. So now comparing the slopes, I see that they're different. So right away, I know that there would be one solution. So we would know what the solution would look like if you did substitution or elimination here. You would get an x value and a y value. Now what about c? How many solutions do we have here? So let's rearrange the first equation by bringing -10x over to the right and then dividing everything by 8. Now when I reduce 10/8, I would get y to equal 5/4x plus 3/8. Now the second equation in our system is already in the form y equals mx plus b. So now let's look at the slopes. The slopes are equal. They're both 5/4. But the y-intercepts are different. So this means we have no solution. So once again, I want to solve the system so you can see what the solution would look like if you did substitution or elimination. Here I'm going to do substitution, seeing as the second equation is already solved for y. Now it was suggested that you should get rid of fractions before you solve, but you don't have to do that. I'm just going to go ahead and plug my y in right here. So when I do that, I would get -10x plus 8 times 5/4x minus 8 equals 3. So now I need to do my distributive property. I got to multiply 8 by 5/4x and by -8. So when I multiply 8 by 5/4, I'm going to reduce the 8 and the 4 to be a 2. and 2 times 5x is 10x. And then 8 times negative 8 is negative 64. Now to solve for x, I'll combine my x's and I'll bring negative 64 over to the right-hand side as well. But when I go to do that, I notice that negative 10x and 10x is going to leave me with 0, and then that's going to equal 67. So this is what it would look like if you were solving substitution or elimination. You will get 0 equaling some number. So this is different than what we saw in A, where we had 0 equals 0. That is a specific case for infinite number solutions. Whenever you get 0 equals some number besides 0, you say that there is no solution. So that's our look at solving systems of equations and the number of solutions. So now you can move on to the next video in this lesson.